Okay, so welcome 2024, question A4, solids in contact. So we're drawn on the right base, okay, shows the elevation incomplete, complete plan of similar sports cone football in contact. Complete the part A, complete the plan and elevation, or the plan of the solids in contact. Now, so we have our elevation. The problem is we don't know how far down to go with our sphere in plan. So what we're going to do the following. So we're going to construct a sphere that's to the side of the cone in elevation, right? So here's the elevation of it. That's it there. Then we're going to get the plan view of that sphere. So we're going to get the plan view of that sphere. That's it there. And we're going to rotate the sphere, okay, to have its center exactly in line with the original elevation. So we're going to rotate that sphere until it's exactly in line with the original elevation. That's what we're going to do. So I'm going to take my I'm going to take my equipment, right? So I'm going to draw a line across here in elevation. It's a tangent to the cone, all right. It's a tangent to the cone and to the XY line, right? So I'm going to draw, okay, a line at 90 degrees to the extreme generator. I'm going to get my compass, get the radius of the sphere. I'm going to step it on this line. So I stepped it on that line, and then I'm going to draw a line parallel to the extreme generator. Okay, from there, there's our center point. There's the point of contact. We'll get our compass. We'll draw in the sphere. So that's the sphere in elevation. When it's out to the side, you get to see the point of contact. Now we're going to drop this center point to plan. We're going to bring this one across. We're going to take our compass. The radius remains the same. So the radius remains the same. And we're going to drop point P onto that. Now, this is the construction to get the sphere in the actual position. So, I'm just going to hide a few planes. So we now have the plan view like this. The sphere is there, the cone is there, and we need to rotate the ball into the position for elevation. So we're going to put our center on the cone, bring the nib to the center of the sphere, rotate, and drop the center from elevation straight down. So compass here on the center of the cone in plan, bring the nib to here, rotate, so rotate the center, drop the center point in elevation. So drop the center of the sphere in elevation, the radius remains the same. So there's the plan view of the sphere. Okay, we join the centers because the point of contact lies between a cone and a sphere, lies in a line joining the two centers when both solids project as circles. Now we're going to rotate P onto that. It's point P. Bring this up and bring this across. Always do this, even if you feel like in the exam they're not asking you for the point of contact. Always do it. It doesn't take long to do. Okay, there's your point of contact. Now part B, draw the elevation, draw the plan and elevation of another sphere which will be in contact with the cone at point P and rest it on the horizontal plane. So here's our point P in plan. Now we're going to set up a sphere, okay, out to the side that touches the cone and touches the horizontal plane. So it's out here, okay, to the side. Now it's going to be a tangent to the cone and to the horizontal plane. So in elevation, alright, it's going to be a tangent to the extreme generator and a tangent to the XY line. So a tangent to the XY line. Now there you go, you see it there. So the center is going to lie on the middle, okay, of the angle between the extreme generator and the XY line. It's going to lie on the middle. So we're going to take our compass and we're going to get point P in elevation. So I'm going to rotate P onto the extreme generator in plan. That's it there. I'm going to bring it up. That's point P there. Now I'm going to do what I was saying to do. We're going to bisect the angle. Alright, now the longer you go on, or the bigger you set your compass to, the more accurate it is. So we're going to take our compass, set it to any radius, and we're going to bisect this angle. Now, if this is the tangent, okay, to establish the center point, we're going to go from the point of contact back at 90 degrees. So look, I'm going to line my set square up with this, alright, line. I'm going to put my T-square underneath. My T-square doesn't have to be tight against the left hand side of the desk. I'm just going to slide my set square on, and I'm going to draw a line here to intersect it. Now there's the center point, there's the point of contact, and then we're going to draw in, okay, our sphere in its construction position. Now the plan view of that sphere, we're going to drop right down and we're going to bring this across. Okay, now this is the plan view of the sphere. It's not touching at the moment the point they want us to touch that, right? So I should say that's P1. They want it to touch point P. So we're going to get our compass now, and we're going to rotate this solid around to touch the point P that they want us for it to touch, right? Wait till I get it here, rotation. So they want to touch it just above here. So they want the sphere touching the cone right there. So we're going to rotate this sphere in plan. So I'm going to rotate that there. I'm going to extend the line here through. The radius remains the same. So I'm going to take this radius. Okay, here's the new center point. I'm going to draw that in. Now, I need to get the elevation of that sphere. So I need to get it that way, and some of the cone will be hidden detail. So I'm going to bring the center up. This arc in plan is a straight line in elevation, so I'm going to go across. I'm going to take my compass. The radius remains the same, so same radius, because the sphere projects as a circle in every view. So there's the elevation of it there. I'm going to bring over the point P in plan. There's the point P in elevation. We mark in our heavy and hidden detail. So there's our hidden detail in plan. Here's our hidden detail in elevation. There's our heavy detail. We'll have a quick look. So our AutoCAD solution, so we can see it there, and we can see what the solids look like in 3D. So that's what the question looked like in 3D. There was the final elevation. There you can see the final elevation and the final plan view. You can see, right, thank you guys.